All right, so this next example right here, there's a few differences between example 1 and example 2. The most obvious one, I think, is that there is no triangle. So I am going to draw a nice, lovely right triangle for us. Okay, it's just going to make everything a little bit more helpful. So there's my nice, lovely right triangle. And I'm going to choose one of these angles to call theta. I want that a color that'll kind of stand out. Let's make it purple. Again, you could have chosen to put it down here. It doesn't matter where theta goes. Just choose somewhere. We're not going to really draw this to scale or anything, but we're going to label our triangle. So find that right angle, go across from it. That side is my hypotenuse. Okay, across from theta is going to be my opposite side, and that leaves this last side to be my adjacent side. All right, now we're going to remind ourselves of our acronym of our Sohcahtoa. Again, I write this on every problem. Okay, I'll write that Sohcahtoa. And then notice they actually gave me two sides of my triangle. You cannot see it. It's kind of hidden right here. But notice they told me the cosine of my angle. So remember that the cosine is just your adjacent over your hypotenuse. So that's my adjacent side over my hypotenuse. So they've really given me two sides. They've told me that my adjacent side is 2. Let's go ahead and mark that. And my hypotenuse side is 3. I guess I didn't need the equal sign. Oops, that was a big one. Hypotenuse, that side is 3 right there. All right, so now we've got to find our missing side, our opposite side, and then we can go through and we can find, in fact, we can already do the secant. This reciprocal is just going to switch places. It's going to be 3/2. But these other two, the sine and the tangent, they both use our opposite side. So we're going to have to use our Pythagorean theorem to find that opposite side very first. Please note, if you go across from your right angle, that hypotenuse has got to be C. Okay, these others, you could call them A and B, it doesn't matter which one. So we've got our A squared plus B squared equals C squared. And then when we plug them in right here, my A I called 2. So I've got 2 squared plus B squared. I'm just going to leave it as B. That's equal to C, or 3 squared. Okay, and then you could just subtract your 2 squared from both sides. So B squared here is equal to 9 minus 4, which is 5. So that's a square. So when I take the square root of both sides, I just have that lovely square root of 5. Okay, so that is my opposite side right there. It's the square root of 5. All right, so when I go through to plug this in, my sine here is the opposite over the hypotenuse. So my opposite is the square root of 5 over the hypotenuse, which is 3. Okay, same thing, let's do the tangent next. So our tangent, our TOA, is going to be the opposite over the adjacent. So my opposite, which is square root of 5, over the adjacent, which is 2. All right, so now when we go to get the reciprocals, there's just one thing else we have to do. We flip it, but look what happens when we flip it. We've got the 3 on the top, the square root of 5. Now it's in the denominator. Remember, they've said that's a no-no. So please remember to what they call rationalize the denominator. Just times it by itself. Okay, so 3 square roots of 5 is going to go on the top. Square root of 5 times square root of 5. If I multiply those together, it's the square root of 25. The square root of 25 is just 5. So that'll go to 5. Same thing happens with the cotangent. It's going to be 2 over the square root of 5. So when I multiply it by the square root of 5 over square root of 5, I will have 2 square roots of 5 over the square root of 25, or 5. And there we've got all 6 of those lovely trig ratios there.